Motor problem solving. In this video, we'll be covering e-bike motor problem solving, the symptoms, the causes, the fixes, and the flowcharts. Why it matters? Because it's how to diagnose and fix e-bike motors efficiently. Prerequisite VODs, a lot of them. Feel free to go back and watch what you need to if you get stuck on any of the concepts. Let's start with the symptoms you may come across. You may see motor-related error codes, or the motor won't spin, or the motor will spin, but it has reduced power or speed, overheats under normal use, is jerky and produces unusual noises or vibrations, or stops spinning after a short time. Causes in a hub motor: compromised bearings, axle and or dropout mounting, detached magnets or other components, broken planetary gear or a sprag clutch in the geared system, wiring faults, loose, broken or damaged wires, cables and connectors, a dead Hall sensor or speed sensor, a shorted phase, overheating or corrosion and rust. In the mid-drive, pretty similar, the only main differences being the broken internal gears or sprag clutch instead of planetary, internal cadence or torque sensor. Fixes: if it's wire, cable and connector related, go to the relevant flowcharts, and otherwise you can replace the different components: axles, bearings, torque arms and or frame if it's really bad, gearing inside the motor, rotor magnets, stator windings, the various sensors, the Hall, torque and cadence, and otherwise the entire motor, depending on the time versus money equation. Let's start by looking at some error codes. So this is the first point that you want to look for. If your system has the capability, it may produce an error code. Usually this will relate to a Hall, phase or open or short circuit or a dead sensor. You can look up the various OEM codes for quicker diagnosis. So for instance, this one is clearly described as a motor Hall error, which ended up being the wire itself, but at least it pointed me in the direction of what parts of the motor I should be looking at first. Speaking of wires, cables and connectors, inside hub motors, they are typically not worth fixing unless you're dealing with an expensive or a rare motor. It's better to replace as possible because this is a pain to do. Especially with smaller motors, you have to basically disconnect and resolder and then put all of these wires through the axle, and it can take a long time. So my recommendation here, if you have damaged wires just near the tip of the axle on a geared hub motor, if you can, it's better to just replace the entire motor because that's going to save you time and money. Axles, we have two examples here. This is a rotor on a BBS HD mid-drive which has a helical gear which is snapped off. Technically that's an axle that goes through a rotor, so you need to replace this entire part with a new one. The sound you're about to hear is the rotor dislodging inside the stator when the axle snaps. The other axles we're talking about is the external ones. If it ends up being the axle is still intact and fine, but the frame and the dropouts are damaged, you need to either reinforce this with a sturdy torque arm or replace the entire frame if you cannot do so. If for whatever reason the axle is actually snapped on the hub drive, then it's just best to replace the entire motor too. It's a pretty rare occurrence for a hub motor, but if you're curious for what it could sound like, check this clip out. So the caliper's actually fine, it's not rubbing on the rotor. Rotate it backwards. Yeah, you've got some resistance here. Free spins forward. I think it could actually be the planetary gears in here. What's happening here is parts of the motor mechanically are rubbing on the shell at certain points due to the axle snapping in the middle and dislodging the alignment of the motor. Something like this is much less obvious and you want to check all the other things first, and when you decided that's not the cause of the problem, that's when you take the motor off the bike and open it up and inspect. Bearings. If you get a lot of rumbling sound, it's best to just replace the bearings if they are sealed cartridge. If they are not sealed cartridge, which I have never seen loose bearings in a motor, then you'd need to replace the entire motor housing. Bearings are typically good for thousands of kilometers, but water ingress can shorten that lifespan. Remember, when it comes to bearings, you want to replace with the same specification, which we covered off in an earlier video. Here's what a dry bearing sounds like. Whereas a fresh new bearing you won't be able to hear at all. The sounds in the second clip were simply a low hum from a fridge, a high frequency sound from the motor's controller, and the motor sound itself, whereas the bearing is practically imperceptible. Gearing and sprag clutches in mid-drives and geared hub motors. The nylon gear on these drives are designed to be the first point of failure. When you have stripped teeth on a gear, as illustrated here below, it can sound like a rapid knocking noise, or you may hear spinning inside the motor, but you might not actually be getting any movement on the chainring or in the wheel. On the chainring if it's mid-drive, or in the wheel if it's a geared hub drive. Problems with clutches usually manifest in two ways. Sometimes you'll get a partial clutch failure, where part of the clutch engages but a different part of the rotation it may slip, usually resulting in a sudden re-engagement or slip. Or you might just get slipping under load, like these examples. And lastly, if your motor's still running okay, but it's making an excessive amount of noise, that usually means you might have dry or worn out gears, like in these examples. Now it's hard to say on each motor, it's usually a case-by-case basis, so the best thing you can do, if you can, is compare it to another motor that's identical to see if it is louder than it should be. If it works, but if the end user still doesn't like the sound, then you can look at replacing the gears if the greasing did not work. The available parts and the serviceability of these gears really depends on each motor manufacturer. Some you may be in luck, others you may need to replace the entire unit. Rotor issues usually come in the flavour of broken or rusted magnets. In this case here, we've had an early X1 Pro prototype basically self-destruct and fling off magnets inside its stator, damaging both the rotor and the stator. And here we have a scooter motor where we can see the outer ring of magnets has basically rusted onto the stator, seizing the motor in place. In most cases, especially these two, it's best to replace both the motor and the stator, so essentially the entire motor. Stator windings. Windings may snag and become cut or torn or end up getting burnt. The laminations also sometimes in these stators can get bent or chipped out of place. In rare circumstances you can rewind these motors, but honestly it is easier to replace the motor itself in 99.9% of cases. One of the more common things to happen is a broken or detached sensor. If it is detached like the speed sensor here, you can try reconnect it or replace it. Hall sensors are pretty cheap and easy to get hold of. Just make sure you get the right part, whether it's active low or active high, and bench test the motor to make sure it's working before you reassemble it and put it back onto the bike, because you don't want to waste time if it's not the right part. But just remember, it's not always the sensor itself that's gone wrong. Sometimes it can be the wiring that leads to the sensor, just like the case of my e-scooter. Now let's jump into the flowcharts. I found it's best to do things in this order. Look for the motor error code if you have one first, and then move down the list to check off each different symptom. Let's run through this chart together. The motor error code, you can check the code, and if it's a simple fix, fix it. Otherwise, the next step, since this chart is for just hub motors, we want to check for an axle spin out at the dropout. The symptom here is you may have that stripped wire coming out of the end of the hub motor, and the axle may be twisted compared to the position of the dropout. You want to check if the torque arms and the dropouts are intact as well as the wiring. If they're not, you may need to replace those parts. Otherwise, move on to the next step. The next thing to check for is the motor not spinning at all, or it spins for a little bit and then it stops suddenly. So can you rotate the motor backwards by hand? In a geared hub motor, doing so engages the gearing, And if you can physically turn the motor, that means mechanically the rotor hasn't rusted in place. Then you want to check your phase circuits to make sure they're intact and haven't shorted. And in the case of the motor stopping spinning after a while, that can usually be related to a speed sensor error. The controller might stop powering the motor if it detects that it's getting no speed signal. If you have any of these problems here, you can end up replacing the part, otherwise move on. Next step, the motor, it's being jerky and there's no constant spin to it. It's usually a hall sensor issue, so you want to check the sensors themselves and the wiring to them to make sure they're intact. If not, replace those parts, otherwise move on to the next symptom, where the motor is actually spinning, but you're getting a whole bunch of random noise, or you might not be getting movement of the motor shell, but it sounds like it's spinning on the inside. Then you want to check for the gearing and the spag clutches being intact. Now, another very rare circumstance you can come across, but it wasn't put in this slide, is on geared hub motors, the axle can actually snap internally, causing alignment issues in the motor, which in turn is actually affecting the gearing. Once you've figured out which part it is, replace it, otherwise move on to the last symptom, which is the motor just overheating under regular use and or producing lower power compared to an identical system. First of all, the problem might not actually be with the motor itself, just check your speed and power settings on your bike, otherwise you may need to change the rider habits. Are they just doing throttle only up a hill with this geared hub motor and it's really bogging it down, where they could be pedaling in a low gear, going slower and taking the stress off the motor? Then we want to move on, just like we would for all of these other things, and does that solve the problem? In this case, if you're still getting overheating, the damage could be done on the motor. So what you want to do is cross swap and test with a fresh motor, and does that solve the problem? If it does, yes, you replace the motor and then the problem is solved. In any of these other scenarios, if you replace the part and that solves the problem, congrats, you fixed it. If not, you need to repeat this process because it may be multiple faults with the same motor, or check the other EV flow charts, starting with the one on wiring, connectors, displays, and controllers. The chart for mid-drive motors is pretty much the same. The only major difference here is play at the bottom bracket. That's where the main axle sits. So this play at the bottom bracket or your extra resistance when you're pedaling could be due to the nuts not being tight enough and the axle and bearings are in okay condition, or is the entire axle out of alignment and therefore causing parts of the motor, like the gearing, to rub on the motor housing. Otherwise, this chart is exactly the same as the hub motor one, so follow all of the same steps. Click here to watch the next video. It is the best free thing you can do to tell YouTube to support the channel. Otherwise, if you want to do more, check out the links in the description. Thanks for watching.